So welcome back. If you have watched the first video on the stress flow curve, we are now studying uniaxial hot compression test on GLEEBLE with aluminum alloys. And so last time we analyzed one single file. This time we will analyze 6 files simultaneously. So in this case, I just say I want to have 6 files. And so the problem now is that you don't have the same thermal expansion contribution here. You see they each have different temperature, therefore the initial diameter before starting the deformation is always different. One way to deal with this is to synchronize all the files together at a point where they are all during the isothermal holding. So I hide the beginning of the data files by just moving here my windowing cursor, and I select operation. Okay, I'm in time on X and dilatometer in Y, right? And so this is the isothermal holding here. So I select operation and synchronize Y, and I will just synchronize it with respect to the file number 2. So number 2, it's the one we have studied before, which is at 73 micrometers. So just synchronize here, and you see all the curves comes together, right? So I can unzoom, and now I have all the curves that are together here at 73 micrometer. I'll export all this data, so they will be saved with an extension OP for operation. And now simply go back in the folder and load them. So we want to load more than 4 files. There is 6 files to load. This is going to start at the position number 2, and you will select every other file. So you see you have here all the files that have been selected automatically. So what's next is that you see you have 2 new columns now. Those 2 new columns, they have been calculated just before with the things which I've been doing. So if we were to plot operation time and operation dilatometer, you see they are all synchronized here. Now remember, to calculate the flow stress curve, what matters is to put on X the strain, that is the diameter, in Y the force that's going to be calculating for the stress, and optionally the stroke. Of course, we have to set ourselves into function mode and select flow stress for cylinder, provide an initial length, an initial diameter, and this contribution for the length in the thermal expansion and for the diameter in the thermal expansion, which is now all equal for all the files. I push the button update plot, and it calculates all the flow stress curves together. So this curve can be, of course, we can then do like we have done before, go back, and now you see you have a third file that can be loaded. So I load 6 files, I start again position 2, and this time we will select every 3 files. And we have now all of these new columns for each of the files. So let's just create a figure to conclude this video, that is diametric through strain and diametric through stress here. The axis would be, so we will round the value of the axis here so that it's going to be more pretty in the graph, and maybe just impose to have a manual axis range from X minima is 0 up to 0.3, seems appropriate here, in Y 0, and in Y max 450 for this case. So we can upload. Actually, you know what I'm going to be doing even is providing a bit more space here. So let's just put 500, so I can put maybe the legend here. Okay, so that would be a possibility. So we can select the point size, or maybe here a little smaller, and save the graph. Can give a legend here if we wanted to for each of those graphs, and save it as a figure. That would be then the figure that could be ready to go. So thank you for watching, and I hope to hear from you if you have any question regarding this video. Have a good day.